Hi, my name is Michelle Bruno, and this is my presentation on hydraulic fracking and earthquake. Hydraulic fracturing causes earthquakes, and that is what my presentation is about today. Um, Annual U.S. gas production was at its peak in 1973, and for the decades after, production decreased as these reservoirs became depleted. Hydraulic fracturing techniques improved in the 90s, and gas production took off again and was above production rates in the 1970s. This increase in production brought gas prices down, but there are some hazards associated with hydraulic fracturing, including earthquakes. What we'll review today is what hydraulic fracking is, how it's done, where it is being done, some benefits and concerns. We'll then go over earthquakes, how they're triggered based on hydraulic fracturing, deep wastewater injection, the history of earthquakes that are induced, some recent events, policies, lawsuits, and then we'll wrap that up. So why do we use hydraulic fracturing? This is also called fracking or HF. Hydraulic fracking is used to increase the permeability of rock formations for the recovery of oil or gas. This is often used in unconventional reservoirs where gas is stored in the rock itself, such as shale gas reservoirs. This technique has been used for years on old oil and gas reservoirs to increase the output. But in the late 90s, technology aided recovery in shale formations. And with that, new locations were found that we would be able to extract oil and gas from. Hydraulic fracturing drilling is done down past the fresh and saltwater tables until the formation has been reached, and then the drilling is then turned horizontally through the shale formation. It's then cemented in place. The horizontal pipe is then perforated where the fracking is to be done, and water and proppant material such as sand or ceramics are sent in to hold open the fractures after they've been opened up. Once the extraction is completed, the gas or oil go back up the well, and then the well is flushed out to remove any excess proppants. Shales such as black shales are a major source of hydrocarbons, and these shale beds can extend horizontally for over thousands of kilometers. They form when large amounts of organic matter are deposited in muds underwater and are then buried in conditions without oxygen. With time and heat, oil is produced from this organic material, and the oil is produced between 2 and 4 kilometers below the surface at depths of 3 to 6 kilometers. There's higher temperatures, and the oil then turns into natural gas. These shales are tightly packed, and their natural fractures are sealed, which restricts the water flow that limits the oxygen to these deposits, allowing them to break down into oil and gas. 3 major locations in the United States that have been produced lately is the Barnett Shale Formation, and that's in the Fort Worth Basin in Texas. And that was formed about 140 million years ago. And these fractures have been sealed in a way that fracking opens them up and allows the injection water to flow through with relative ease without closing back up. This is one of the largest producers of natural gas in the U.S. The Bakken Shale Formation is located in the Western Canada Basin and was formed between 130 or 340 to 385 million years ago. The Bakken Shale produces large amounts of oil, and much of this is coming from North Dakota as it extends there into northern United States. It is a horizontal formation with tightly sealed fractures and has a very high success rate with fracking oil and gas from the shale formation. Marcellus Shale is located in the Appalachian Basin, which covers Pennsylvania, New York, West Virginia, and Ohio, and it was formed about 350 million years ago. It is estimated to contain 50 to 500 trillion cubic feet of natural gas, and horizontal drilling is done with the extensive fracking to extract gas from this formation. Some benefits of hydraulic fracturing are economic. The increased natural gas production from hydraulic fracturing has reduced the price of gas from about $8 per thousand cubic feet in January 2006 to $2.89 per thousand cubic feet in January 2012. Health-wise, using natural gas from fracking as opposed to coal for our electricity generation is better for public health as it produces less nitrogen oxide and sulfur dioxide. Coal made up about 50% of the electricity generation in the United States in 2008, and it was down to 37% by 2012. And in that same time frame, gas increased from 20 to 30%. Water usage per energy unit of gas is lower than coal and nuclear energy. And corn ethanol can use up to 1,000 times more water due to irrigation reasons than hydraulic fracking does. Some concerns around hydraulic fracking is also the water. That's a benefit and a concern, as large volumes of water are still needed for this process. It can cause a reduction in water available for other purposes then. This water can also be contaminated, as the water returning from the wells has additives, and it also can pick up natural items such as large amounts of salts and radioactive isotopes from underground. Spills can contaminate groundwater, and this is often injected into a lower sedimentary layer, and this disposal can cause leakage. Methane gas. There are some wells in the area of the Bakken Shale in North Dakota that have large amounts of oil and gas. They actually do not have enough pipeline to collect all the gas, so they do burn off the extra, and this burning is called flaring. Flaring actually causes air pollution, greenhouse gases, and is a waste of a non-renewable resource. Presently, Alaska injects the excess gas back down into the formation, and hopefully North Dakota will be following along in the same suit. Earthquakes is the other item I was touching on. Hydraulic fracturing creates many small earthquakes, but it can also cause larger earthquakes. Most often, damage-causing earthquakes are caused by wastewater injection and not the fracking itself. Earthquakes can be induced from mining, withdrawal of fluids and gas from subsurface areas, and injection of fluids into underground formations. Earthquakes are more expected in areas where tectonic plates are located, such as the San Andreas Fault in California. But any faults that are under stress can be triggered, such as with injection. How it works is earthquakes release the stored energy when the fault slips. The fault will remain in place if the friction is strong enough to maintain the contact. Changing variables in this environment, such as reducing the friction or applying additional pressure, can trigger the fault to slip and then the resulting earthquake. This seismic activity then travels away from the center and Current techniques to record these events cannot actually determine which earthquakes are triggered naturally and which ones are man made. The hydraulic fracturing, as I stated, causes many little micro earthquakes, and most of them are not do not cause damage, but some can be felt. The major issue is with the deep wastewater disposal injection, and those have been shown to cause more earthquakes than the hydraulic fracking itself. Some history in regards to induced earthquakes is the first one recorded was in the Rocky Mountain Arsenal. This was the first signs of injection induced earthquakes in 1961. They were drilling and injecting into disposal wells for a chemical weapons plant at the Rocky Mountain Arsenal. Between the start of injection in 1961 and the end in 1966, there were 13 earthquakes over 4 in magnitude. In 1967, there were 3 earthquakes that were recorded over 4.8 that caused minor structure damage, and the earthquakes were traveling as far as 10 kilometers from the injection well. Tremors were actually felt for months after, with more than 700 earthquakes from 1962 to 1966. The U.S. Army did shut down the disposal wells in 1966, but the earthquakes grew and the fluid and pressure disturbed new faults. The tremors were felt actually until 1981. This Rocky Mountain Arsenal study shows how the fault system can be triggered due to changing pressures, which can then travel from the injection site, and that effects can be delayed by months or even years. Rangley Oil Fields, a seismologist, did a study with the USGS in 1969 using a Chevron oil well that was on a seismically active zone in Colorado. They injected water and they turned it on and off in a well that was being used for petroleum production simulations. What they did was they followed the fluid pressure through the rocks and found the injection pressure that triggered the earthquakes. Any pressures that were above that triggering point caused an event. When the pressure was below the trigger point, the tremors were much less. When the water was allowed to flow back, the earthquake activity stopped within 1 day. If the stress conditions and the strength of the rocks in the fault are known, the seismic activity could be controlled by adjusting these pressures. On Paradox Valley, the Dolores River runs through there, and they were trying to reduce the salinity in the river. It runs over a saline shallow water table, and the U.S. Bureau of Reclamation determined that the best way to reduce the salinity of the river was to inject that water about 4 miles below the surface. They did recognize the need to minimize the magnitude of earthquakes after Rangley and the RMA studies. So studies were done between 85 and 1996 prior to the well being drilled and during testing. During this time frame, only 3 earthquakes were detected within 15 miles and 12 within 35 kilometers of the well. During testing between 91 and 95, there were hundreds detected, with most of them being within one mile of the injection site, and all the events were below a 3 magnitude. High pressure was needed to meet the requirements for disposal of the well, of this water, and during the first few years, events over magnitude 3 led to adjustments in procedures to reduce the maximum magnitude. The earthquakes were also noted to be farther from the injection point, increasing the seismically active zone. They did shut down occasionally for 20 days to help the system come to an equilibrium, but it proved inadequate as there were magnitude 4.3 events in the year 2000. This example shows how high volume injection over long term can expand the seismically active region and trigger events farther away from the injection site than would have naturally happened. It also shows the difficulty managing earthquake risk once the events have begun. Some recent events in the Dallas-Fort Worth area, they had their first earthquake in 2008. And since then, they have had over 200 events in the Dallas-Fort Worth area. And this is a 6-fold increase over historic levels. What they found was there was a wastewater well near the Dallas-Fort Worth airport, which was less than a mile from the epicenter of the earthquakes. And large amounts of wastewater were being injected that year. It went from 33.8 million barrels in a month to 81.1. In Youngstown, Ohio, in 2011, more than 100 tremors were recorded. Prior to this, there had been no reported earthquakes in the area. In December of 2010, a disposal injection well to remove wastewater from a nearby Pennsylvania fracking operation was brought online. The data analyzed show a correlation to the starting and operating days of the well, with the first earthquake happening just 13 days after the start of the operation. Dips in the number of earthquakes were seen when the well was not in operation, including holidays. These earthquakes were found to be along subsurface faults that traveled down the fault due to the increased pressure from the fracking wastewater disposal. In Prague, Oklahoma, they experienced an increase in seismic activity in the recent years. There was a 5.6 magnitude earthquake, and that was felt as far away as Chicago. Currently, there are 3,800 wastewater disposal wells, and there has been over 3,500 earthquakes in 2005. Over 3 in magnitude, there were 900 of them. This is a 160-fold spike in earthquakes in Oklahoma. And as of 2014, Oklahoma has surpassed California's earthquake rate. Katie Kiernan, a seismologist at the University of Oklahoma, did a study on the 5.6 earthquake in 2011. And the model showed that pressures could have caused the earthquake and that the tremors following by causing the faults to slip in a domino type effect. The paper published by Kiernan and her colleagues tied the ejection wells outside of Prague to the earthquakes. The Horn River Basin in Canada had no prior events to 2009, but in 2009 they did have 40 events. These coincided with injection days during operations at local wells. Some policies that have been updated recently in regards to earthquakes. Kansas doesn't have much fracking operations, but they had events near their Oklahoma border, and they were quick to implement restrictions on injection volumes to cut down on the number of events. While it hasn't fully solved the problem, they have seen a reduction. Ohio added additional seismic stations to record lower level magnitude earthquakes, and anything that's a 2.0 magnitude can trigger a shutdown or investigations at hydraulic fracturing operations. Texas was reluctant to change regulations, even with multiple published findings that cited hydraulic fracturing and disposal contributing to the earthquake events. But they do have well operators currently include USGS surveys results in their applications for wastewater injections so that they can reduce earthquakes and injections by triggering the faults. On February 13th in 2011, Prague, Oklahoma, a 5.6 magnitude earthquake trembled through the town. This event caused property damage and personal injury to Sandra Laudra. Sandra then sued Spice Oil Company and New Dominion Energy, claiming injury and loss due to the hydraulic fracturing operations. While the case was dismissed by the state, a district court denied the motion for dismissal, and it is now pending. This case is one of only 6 in Oklahoma to survive, with more than 40 lawsuits across the United States being settled quietly or dismissed. Many are watching this case as no one knows the cost of the other settlements, and this may cause changes in the marketplace. Companies are trying to contain these costs and minimize incentives for future lawsuits. This lawsuit raised concerns for insurance underwriters as well, as they may withdraw from the market of insuring these companies based on risk, or they may have exclusion laws. In conclusion, the risk of damage induced by earthquakes from hydraulic fracturing is relatively small, since these earthquakes are mostly below the damage threshold for modern buildings. Where we need to address is around wastewater injection wells. Seismic activity thresholds need set to include injection reduction and suspension if the seismic activity continues. Lowering the threshold in areas where the activity is more frequent and having a better geological understanding of the area and the thresholds in each location would help to make these guidelines more relevant as each area is unique. The USGS and the Oklahoma Geological Survey issued warnings in 2013 and 2014, stating that there is a significantly high chance of seeing a 5.5 earthquake or higher in Oklahoma. This is one of the first times the USGS issued a warning of such east of the Rockies. In 2015, Oklahoma had asked that 600 wells cut their injection volumes by 40% below the 2014 levels. While this reduced the amount of fluids, injections are still being done and can still cause earthquakes. The OSGS in April 2015 stated it's very likely that the majority of recent earthquakes, particularly those in central and northern central Oklahoma, are triggered by the injection of produced water in disposal wells. With the economic dependence on oil and gas in Oklahoma, the OGS was slow to come to these decisions as they were trying to balance the economic impact along with trying to be responsible at the same time. Experts state that even if all the wells in Oklahoma were shut down, there is no way to know when the earthquakes would stop. Calculating the pressure that is currently in the area and with the amount of earthquakes that are happening, they have a difficult time estimating how long these earthquakes may continue. While hydraulic fracking is beneficial to our energy production and jobs in the United States, the disposal of the wastewater is causing property damage and personal injury, and that risk needs to be mitigated. It seems as if steps are being taken to manage these risks, but in the long run, these oil and gas reserves will eventually run dry. And I feel that now is the time for us to look into more alternative energy resources, including wind, water, and solar energy. Thank you.